Welcome, secret agents. I'm your host, and today's explainer is your insider's playbook to mastering the Cambridge 9618 syllabus. Your mission, should you choose to accept it, is to extract maximum marks from a hostile computer science exam paper. Let's set the scene, all right? We've got two distinct approaches from a real past paper. First, we have Alex. Now, Alex just overloads the answer sheet with a raw computer science facts, but entirely misses the analysis. Then, we have Sam. Sam rushes the extraction and completely misses the command word requirements. Just picture all those dreaded red pen marks bleeding across a rush paper. Well, today, we're going to fix that. We are going to turn those red marks into green check marks.
Okay, let's dive into this massive number, 15. Did you know that instruction groups, specifically data movement, accounts for approximately 15% of your total marks on paper 2? Seriously, that is a massive chunk of your grade just sitting right there, waiting to be extracted. It's literally the difference between an average grade and top-tier mastery.
To secure those points, we need a flawless strategy. We're going to map this out by covering the core conceptual architecture, the technical methodology, deconstruct, solve, evaluate, the top 3 examiner's warnings, and finally, the final extraction system.
Section 1. Core Conceptual Architecture, the foundation of data movement. Let's start with our first mission objective, understanding the theoretical architecture that examiners are actively hunting for when they grade your paper.
So the absolutely crucial point here is that top-tier students achieve significantly higher marks simply by referencing cross-topic connections within this framework. You see, the data movement framework isn't just about memorizing what an instruction does. It relies on precise definitions, causal relationships, and integration with other areas of the 9618 syllabus. Remember Alex? When Alex just listed facts, he completely missed the causal relationships. He didn't show the examiner exactly why data moving from point A to point B mattered to the rest of the system.
And this brilliantly illustrates the 3 distinct cognitive domains examiners use to test your mastery of the subject: knowledge and understanding, application, and analysis. To nail all 3 of these, top students use what we call the PEEL framework: point, evidence, explanation, and link. So you make your point using precise definitions for knowledge. You provide evidence and explanation through systematic reasoning for analysis, and then you link it back to the scenario for application. Honestly, if your answer doesn't have all 4 parts of PEEL, you are leaving marks behind.
Section 2. Technical Methodology. Earning the method mark. Now, let's jump into how to earn those critical method marks, where your field tactics come into play. But real quick, before we continue and reveal how to practically apply this, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations.
Algorithmic thinking in this topic requires following an exact 4-step procedural sequence to build a functional solution. First up, step-by-step decomposition, basically breaking the hostile problem into manageable chunks. Second, data structure selection. Third, efficient code implementation. And fourth, rigorous testing. Now, when you're under the pressure of the exam clock, you absolutely cannot skip straight to code implementation. That's exactly what Sam did, and honestly, it caused a total mission failure.
Now, here is the secret to the method mark strategy. Examiners actually award you points purely for demonstrating this systematic process, even if your final output has a flaw. Think about that for a second. You can get the final code slightly wrong, but if the examiner can see your clear working, if they see your decomposition and logical structure, they are going to award you method marks. It's like turning a guaranteed red mark into a partial green check mark just by showing your thought process.
To lock these procedural steps into your brain quickly, use a visual story method to encode the concepts as an unbroken narrative chain. Imagine the data as a physical briefcase you have to safely move across a treacherous bridge. You have to check the bridge. That's your data structure. You have to walk across it logically. That's your code. And you have to make sure you don't fall. That's your testing. Visualizing it this way ensures you never skip a step when the timer is ticking down. Section 3. Deconstruct, solve, evaluate. The interactive workshop. Welcome to your interactive workshop to hone your skills before stepping into the field. But wait, stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Join thousands who have improved by 2 to 3 grade boundaries and turn on all notifications.
Let's see how this builds the ultimate 5-step problem-solving matrix required for those higher-order assessment objectives. Specifically, I want you to notice those final 2 steps: check for reasonableness and make justified recommendations. This right here is where higher-order marks live. You aren't just solving the problem, you are evaluating the solution. So, let's actually put this into practice right now.
Imagine you're scanning a hostile exam paper right now. You must identify the key elements before you can even begin to design an algorithm. Challenge 1 is the data scan. If you had 60 seconds on the clock right now, could you pull out the absolute core trend from a complex scenario? Your brain needs to quickly filter out the noise and instantly highlight the variables and the expected output.
Let's move to challenge 2, find the flaw. Think about a student like Sam who rushes and completely misses the command word requirements. Their failure to evaluate alternatives or provide justified recommendations is going to cost them dearly here. If the command word says evaluate and you just describe, you literally score 0 for that section. No way around it. You have to decode the command word first, apply the Peel framework, and ensure your final sentence actually answers the specific prompt.
Section 4. Top 3 Examiner Warnings, How Not to Lose Marks. Now that you know how to earn the marks, we need to look at the principal examiner reports to see exactly how students lose them. This is straight from the source, the actual people grading your papers. Here are the top 3 fatal mistakes. First, confusing cause and effect within data movement. Second, completely ignoring boundary conditions and edge cases during testing. Seriously, if you don't test what happens at the extreme limits of your data, your code just isn't robust. And third, writing answers that are completely detached from the scenario.
Providing generic textbook answers is the classic trap, whereas linking every single point to the context guarantees top marks. For example, if the exam asks about a database for a hospital, and you write a brilliant explanation of data movement but never once mention patients or medical records, you will be penalized. That is the generic answer trap. The green checkmarks go to the students who write contextual answers. So, the ultimate examiner alert is this: your knowledge is completely useless unless it is specifically contextualized to the problem right in front of you. This is the link part of the Peel framework we discussed earlier. You must loop your brilliant technical explanation back to the exact scenario the examiner provided.
Section 5, the final extraction system, securing your grade. Let's synthesize all of this intelligence into one final, foolproof system to deploy during your exam. You've seen the traps, you've seen the frameworks, so now let's bring it all together for your final objective.
When you execute your analysis with exceptionally clear working and systematically verify your results, you become an unstoppable force in the exam room. First, decode the command word and apply the relevant principles. Second, use the PLL framework to execute your analysis, leaving a clear trail of working so you capture every single method mark available. And third, manage your time matrix to verify your results and format them exactly as requested. Students who consistently implement these specific data movement strategies see an average improvement of 2 full grade boundaries. 2! The method works, but only if you apply it systematically under pressure. That means trusting your training, breaking down the problem, and deploying the Peel framework step by step without skipping ahead. Oh, and here's your final reminder to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. As we wrap up our mission today, ask yourself, what is your target grade for computer science? And what is the single biggest exam challenge you are facing right now? Drop a comment below with your target grade and your biggest challenge. Keep your working clear, keep your analysis sharp, and remember, the exam isn't testing just what you know, it's testing how you apply it. Good luck out there, agents, and until our next explainer, keep up the hard work.